Welcome to sitza.com. Electrophilic aromatic substitution reactions. In a benzene molecule, we have alternate single and double bonds, and these electrons over here, which are in conjugation, they are under resonance, so they are delocalized, and that provides stability to the molecule. So because of it, aromatic compounds are very much stable. Benzene is very stable, so that's why it doesn't undergo the addition reactions so often, right? So a normal double bond, it can undergo the addition reaction, you can break the pi bond, but here this addition reaction doesn't take place. In the aromatic compounds, the most common reaction is a substitution reaction, electrophilic aromatic substitution reaction. Actually, you can remove this particular hydrogen atom from the benzene ring. You can remove this particular hydrogen by any electrophile, right? So an electrophile is a species which is electron deficient, correct? So electrophile is electron deficient, and this electrophile can replace a hydrogen from the benzene ring as H positive, and if you replace it here, what you will get, you get a benzene ring over here with the double bonds there and having an electrophile, and you replace the hydrogen as an H positive. This is what you call as an electrophilic aromatic substitution reactions. So I can say this is an EAS reaction, which is electrophilic aromatic substitution reaction. Let's see the mechanism of this electrophilic aromatic substitution reaction. So how you can replace this hydrogen from the aromatic ring. In the first step of this mechanism of this electrophilic aromatic substitution reaction, we see the electrophile attacks on the aromatic ring, and if you look at here, this double bond, this particular bond, which is formed by the sharing of electrons between these two carbon atoms, these are the two electrons being shared by the two carbon atoms. And over here, what you see, we find that it is the electrophile that approach this the double bond, and this double bond, this electron, it can form a bond with the electrophile, because electrophile is electron deficient, and it can form a bond with it. And then what you will get, you get a molecule, you get an intermediate somewhat like this. Let me draw the structure here, double bond, and you have a hydrogen at each carbon atom. I'm going to show only two hydrogen atoms over here. Now see, if this particular electron, if it goes to the electrophile, and this carbon forms now a bond with the electrophile, so you have an electrophile over here, and this carbon over here, this particular carbon over here, which has lost an electron, will get a positive charge. So it is a positively charged carbocation, and this positively charged carbocation can undergo the resonance. Actually, this is very much stable due to the resonance, right? We have a double bond over here, you have a double bond, there is an electron pair over here, and it can shift in this direction, and you can get a one more resonating structure for this particular carbocation. You have a double bond over here, you have a positive charge over here, you have a double bond here, we have an electrophile and a hydrogen over here, you have a hydrogen here also, and again you can draw one more resonating structure over here, where you can see this particular carbocation, it can undergo the resonance, right? It will be delocalized over here, and therefore you get a double bond here, and now this is a positively charged carbocation, and here is an electrophile. Okay, so you can see an hydrogen, and here we have a hydrogen. Now these are the different canonical structures. This can go back forth, you get this one, and this goes back here into the first one. So these are basically the different resonating structures of this particular carbocation that you get after the attack of an electrophile. So this is the first step that you see in the electrophilic aromatic substitution reactions over here. Now what happens in the next? So the next step here is this particular carbocation over here, now it will release a proton. See, we have a bond between a carbon and a hydrogen, which is this is the electron pair, and if you look at this particular hydrogen atom, if it is lost as an H positive, the electrons go inside the ring, and therefore after the loss of hydrogen H positive, when you release this hydrogen as an H positive, the electrons go inside the ring. So what do you see? We get a benzene ring, an aromatic ring. We have two double bonds over here. We have an electrophile over here, and now this hydrogen, when it is lost and the electrons go inside, the ring and they form a bond with this particular carbocation. So you have now a double bond, right? Okay, this is our product. This is the product which is formed when hydrogen is lost as H positive by the electrophile. So this is the mechanism of an electrophilic aromatic substitution reaction over here.